All right. Well, welcome everyone who's physically present and welcome everyone who's virtually present. My job is a really fun one today is to tell you about what many people are calling the sky event of the decade. August 21, there will be a total eclipse visible from one country and one country only, and that's the United States. They're already calling it the All-American eclipse. I'm sure the administration in Washington is going to try to take full credit for it. The minute they wake up to the fact that it's happening, they're a little busy shuffling the deck chairs on the Titanic right now. But there will eventually, I think, be a big claim for this. And it is interesting that the eclipse is total only in the United States. What's going to happen? Well, during an eclipse, the moon covers the sun. And if you think about that, that's a really remarkable coincidence. As seen from Earth, the moon in the sky and the sun in the sky happen to be exactly the same size. That's not true, by the way, from any other planet-moon combination in the solar system. Only from Earth is that true. In case you don't believe me, here is one of the moons of Mars trying to eclipse the sun as seen from Mars, and you can see it's pathetic. Right? There's a little rock called Phobos can't possibly eclipse the sun. But here from Earth, the moon and the sun are the same size, so an eclipse works. Here's what's happening during an eclipse geometrically. The moon gets in front of the sun, and therefore the shadow of the moon makes a dark spot on the Earth. Now, the nice thing is the Earth turns. That's what it does for a living. That's what it says on its business card, right? And the moon moves in its orbit, and the relative motion makes the shadow spot of the eclipse move across the Earth. And that's what's going to happen on August 21st in a zone about 60 to 70 miles wide. The eclipse spot will move across the United States, starting on one side of the country, on the Pacific side, all the way to the Atlantic side. Just in case you don't believe me, here is a previous eclipse as seen from space, and there really is a shadow spot during the eclipse right on the Earth. When this happens, here's the sequence of events. This is a beautiful sequence of photographs put together by my colleague Rick Feinberg. But you can see the sun slowly begins to see the moon encroaching it. The moon moves across it. Then when the eclipse is total, the sky goes dark and night comes in the middle of the day. It's really spectacular. The stars actually come out, and around the sun this faint but beautiful halo is visible. That's the sun's atmosphere. Usually we don't see the sun's atmosphere because the sun's main body is so bright. But when the main body of the sun is actually totally eclipsed, then the faint atmosphere becomes visible. We'll talk more about that atmosphere in a little while. But then eventually, and in this case only 2.5 minutes later, but eventually the moon moves away from being directly in front of the sun, and after the moon moves completely off the sun is restored to its former glory. That's the sequence of events. Now, for those of you who are interested in seeing the total eclipse, here's the big event before the eclipse becomes total. Here you see a flash of light from the very last valley around the mountains of the moon, which is letting sunlight through. People call this the diamond ring effect because it looks like there's a ring of light already and then one flash in that valley, which makes for the diamond in the diamond ring. So this is your clue that the eclipse is about to go total. When we have a total eclipse, then, as I say, the faint atmosphere of the sun comes out. This is taken through a telescope, so here we can actually see prominences, great tongues of hot material that jet out from the surface of the sun. Some fall back, some are released into space. Here's the situation for the dark eclipse spot on Earth on August 21. It starts out in the Pacific, then moves across the country, going diagonally down until it reaches South Carolina, where it then goes off the United States and into the Atlantic Ocean. Here's a list of states which are going to be seeing the total eclipse. But remember, not all of each of these states is going to see it, only a 60 to 70 mile wide path. By the way, all these slides are part of a free booklet that I'm going to tell you toward the end of the talk how you can get off the web. So if you want to send that map or the little charts that I'm going to show you to friends, relatives, colleagues, there'll be a way to get all this information out. You don't need to take notes, and I promise this won't be on the quiz. But these are the states where it's visible. And the interesting thing about the eclipse is that no major metropolitan area will see the total eclipse. A tiny corner of St. Louis will have a total eclipse. Nashville, Tennessee will have the total eclipse. But mostly it's small towns, rural areas, national parks, state parks, etc. So this is going to be a non-urban eclipse for the most part. I think Airbnb is going to clean up on this eclipse because there are many more private residences and farms than there are major hotels in the eclipse zone. Here, for example, is our nearest state, which has the total eclipse. That's Oregon. And you'll notice that in Oregon, the eclipse is not going to go over Portland, the big city. It's not going to go over Eugene, where the University of Oregon is. It's going to go through central Oregon, relatively small towns for the most part in central Oregon. The towns that do get the total eclipse are beside themselves with excitement. For example, Hopkinsville, Kentucky is going to have the longest eclipse just by the geometry of things. They'll have 2 minutes and 40 seconds of eclipse. So they're already advertising the most exciting 2 minutes and 40 seconds in astronomy, which is a takeoff on the Kentucky Derby, which is in Kentucky, which is the most exciting 2 minutes in sports. So the calculations by Michael Zeiler, a cartographer and geographer, indicate that about 12 million Americans live within the path of the total solar eclipse, which is about 4% of the country. So if a couple of 100,000 visitors come into that area and join the people already living there to enjoy the eclipse, that should be fine. And there have been many, many eclipse aficionados who have been planning for years to go into this eclipse zone. So that's not the problem. Here's what we are deathly scared about. 47 million Americans live within a 100-mile drive of the eclipse. And so, if in mobile America, right, where so many people have cars, 10 million of these people decide the last weekend, hey, honey, let's grab the kids, put them in the car, drive 100 miles, and we'll see the eclipse. Those 10 million additional people will completely overwhelm the services, the roads, etc., in that rural area of the country. I won't even begin to think of how many people live 200 miles within the eclipse, which many of us drive when we have to. So it's going to be a real problem. And here's the biggest issue in everyone's mind. And seriously, if there are an extra million to 10 million people in those areas, where are they going to go to the bathroom? Right? All the porta potties in those states have already been spoken for, but there's serious concern that there may not be enough facilities. So what we're telling people is don't leave your eclipse planning for the last minute. Those people wise enough, like all of you listening to this talk, to have advance notice of the eclipse, please plan ahead. Try to be where the eclipse is total if you're going to see it the day before, not that morning. Because that morning, we expect it to look like this. And this is, of course, misleading because look at all the lanes on this crowded freeway. Most of the roads in the eclipse zone are nothing like this. They're not freeways. They're small roads, country roads, 1-lane, 2-lane places. So it's going to be a real challenge navigating just before and just after the eclipse. Now, the rest of the country is going to see a partial eclipse. If you are off this dark spot, then the sun will not completely be covered. The moon will only cover part of the sun. But in the United States, pretty much everywhere, a substantial bite will be taken out of the sun. And this eclipse, the partial eclipse, will be visible, we think, to almost 500 million people in North America, because Canada and Mexico and even parts of the countries below Mexico, south of Mexico, will be able to see it. So about 500 million people will be able to see the partial eclipse. And because when the eclipse is partial, the sun is still out, it's dangerous to look at for any length of time. So we would really need some way to teach all those 500 million people how to observe the eclipse safely. And I'm on the National Task Force of the American Astronomical Society, which has been working for 2 years to prepare the country for the eclipse. And this is what we look like at typical meetings, right? 500 million people. What are we going to do about all those people? They're all going to need some way to protect their eyes. And the best is glasses. There are inexpensive paper and plastic glasses which are perfect for protecting your eyes. Those Google employees who had the good sense to actually physically come to the lecture have gotten free glasses. The rest of you there, I will leave to Calvin to explain how people can get glasses. But glasses are one easy way to do this. Now, let me show you the circumstances of the partial eclipse for the largest cities in the United States. They're really quite interesting. And again, if you want to have this chart, it'll be in the free booklet that I tell you about a little bit later. But notice in New York City, just look at the last column, 71% of the sun's area will be covered. That's not bad. Los Angeles, 62% of the sun will be covered. Here in the San Francisco Bay Area, 76% of the sun will be covered. And in Washington, D.C., the cover-up will be about 81%. And that's pretty typical of the cover-up in Washington, D.C. No, I didn't say that. Here in the San Francisco Bay Area, here are the circumstances of the eclipse. So the partial eclipse for us begins at 9:01 when most people are arriving at work. The eclipse is at maximum, 3/4 of the sun covered, at 10:15 a.m., and it's all over by 11:37 a.m. So if you're planning for that Monday in August, the crucial times here in the Bay Area will be from about 10 to 10:30. That's when I would make a special point of being outside with the glasses and looking at the sun. A large dark bite will be taken out of the sun. The sunny day, if it's a sunny day where you're looking, will look like a more cloudy day as the moon goes across the sun. Where the eclipse is total, it'll be much more spectacular. But again, as I mentioned, only a small set of relatively small towns will get to see the total eclipse. Salem, Oregon, Casper, Wyoming, St. Joseph, Missouri, Carbondale, Illinois. They are going nuts in Carbondale, Illinois. This is the biggest thing that's happening in Carbondale, Illinois. Another big factor in terms of your enjoyment of this eclipse, whether it's total or partial, is the weather. If it's completely cloudy, or as often happens in San Francisco, completely foggy, you will not be able to enjoy the eclipse. So the world's expert on eclipse weather is Jay Anderson, this jovial Canadian meteorologist. He has a whole website updating the weather constantly called eclipsophile.com, but you don't need to go to his website. All the other websites steal the information from him and put it up because he's been keeping track of decades of weather on August 21 to be able to make a statistical prediction for the likelihood of cloud cover in any place on August 21. And here's a quick summary of his most recent findings. On this chart, you go from left to right across the United States. So the Pacific coast is on the left, the Atlantic coast is on the right, and then up and down, the further up you go, the more likelihood of cloud cover. So you can see the red line on this chart. Basically, there's a great variation from less than 40% in Oregon and parts of Idaho to almost 80% in South Carolina in terms of the likelihood of cloud cover. So those of you on the west coast here, congratulations for picking the better coast for eclipse weather. But this will be an important factor. And again, our fear is that if there are thousands of people in some total eclipse location who have planned for years to be there for this sky spectacular, and in their location the clouds come, they're not going to be okay with that. They're going to want to move, right? And these herds of people will try to get out of the cloudy area to where it's sunny, and there'll be incredible gridlock in terms of cars or people trying to walk or anything like that. So paying attention in advance to the weather predictions is also a good idea as you're making your eclipse plans. Now, as I say, this will be a Monday in August. And from the best we can tell, about half the schools in the United States will be in session and half the schools won't. So half the kids will be with their parents and half the kids will be with their teachers. But for many school districts, that's the first day of instruction. That's true, for example, in San Francisco and Oakland. Both of them have the first day of school will be August 21. So you can just imagine this. The kids come in and they say, who's my teacher? Or here's my teacher. The teacher gives their name and then says, okay, now there's an eclipse. What are they going to do? Are they going to go outside? Will they be ready? Will they be prepared? And we have no idea. We've been working with teachers for 2 years. We've been doing seminars and webinars and training workshops and putting out materials. I'll tell you more about that in a second. But still, for the most part, particularly in elementary schools, most teachers are not yet aware that the eclipse is happening. And like many members of the public, they may only wake up to this relatively close to the eclipse itself when the mainstream media begin to make a big deal of this. So if you know where your children are going to be that day, try to make preparations for them to be safe and educated, that is to have information available. Many people who get information about the eclipse in one of these talks that I'm giving over the web, we're encouraging them to share that with their child's teacher to make sure that the teacher's aware of what's happening, maybe see if the teacher or the school can order glasses, eclipse glasses for the whole class, help them out if they can't, and take a look at what's going on. Now I have an update thing here on my screen. Can you help me with that, Rob? Okay, great. All right. So there's a lot of misinformation out there about the eclipse already. For example, people get mixed up between a lunar and a solar eclipse. A solar eclipse, as long as the sun is out, it's relatively dangerous to look at, and you need your glasses. And we've known this for some time. This is a headline from 1918. That was the last time an eclipse crossed the United States. And it says, thousands point glasses at sun to watch eclipse. Very relevant today, except cross out the thousands and write millions. I'm sorry?
It's a similar path.
A similar path, yeah.
The same stars?
It's, we'd have to calculate that.
Okay.
All right, so eclipse glasses are available from 2 companies in the United States, American Paper Optics and Rainbow Symphony. But of course, they're overwhelmed with orders. So the earlier you can order your eclipse glasses, the better. But eclipse glasses will also be available in many other places. Every science museum has them. Foothill College bookstore has them. I'm sure that hardware stores will have them. There's talk of Walmart perhaps having some.
Grocery stores have them.
Who has it?
At least 3 grocery stores have been in the
3 grocery stores. So people have ordered them, and it's sort of chance. But of course, we worried quite a bit about how to distribute glasses to people who may not be prepared for this, who will need them. And I actually thought to myself, where could we distribute glasses to people who don't usually get to share in events like this? And that's when we hit on this great idea of public libraries. Public libraries are in the information distribution business. And so if we could somehow get glasses to public libraries, that would be really, really wonderful. And so I'm really pleased to say that you guys, Google, joined with a foundation here on the peninsula, the Gordon and Betty Moore Foundation, and through your generosity, we have now distributed 2 million Eclipse glasses free of charge to public libraries around the country. And I want to applaud all of you at Google for doing this. Calvin, thank you so much for being an important part of this. Here's a now no longer current map, but it just gives you the first 2,000 Eclipse glasses libraries. We're now up to 5,000 libraries. And by the way, inspired by how popular this program has been and what you guys have done, NASA has now come in and donated another 100,000 glasses. So we hope to be up to 6,000 libraries within the next week. So people at 6,000 libraries around the country will be able to get free glasses. And we've sent them information booklets and ways to have Eclipse events at each library. And I was telling Calvin, I've been speaking at libraries around the Bay Area, and at every library, it's been standing room only. There's been just tremendous interest in the Eclipse. We're getting some help from the U.S. Postal Service. The U.S. Postal Service issued an Eclipse stamp on June 20th, which is the first ever thermochromic ink stamp. And you all know what that means, right? No, I had no, what the heck is thermochromic? But it's really cool. It turns out there's an ink where if you touch it, the picture changes. So if the heat of your finger touches the stamp on the left, it turns into the stamp on the right. And this is a real collector's item. Many post offices are already out, but you can always order the stamps at the U.S. Postal Service website, usps.gov, if you want to get your own souvenir Eclipse stamp. All right. So as I say, you guys will have your glasses, but what about people who don't have glasses? What are some safe ways of observing the eclipse if you don't happen to have access to these paper and plastic glasses? Well, there are a number of things you can do. If you have a tripod with binoculars, you can cover up one half of the binoculars, make a sunshade around the other half, and then project an image through the binoculars onto a white sheet of paper. The sunshade makes for a dark background on which you can see the eclipse. So if you are comfortable and familiar with setting that up, that's one way to do it. A much simpler way to safely view the eclipse if you don't have glasses is to take a hand mirror or a woman's compact mirror, cover it with cardboard, leaving only a hole about the size of a dime. And then take that small mirror, the leftover mirror part, and project an image, reflect an image onto a wall. So you try to get the sun into the mirror and then make an image appear on a wall where a number of people can look at it. Now, don't try this for the first time on August 21. It takes a little practice to be able to do it. So what I would do is to go out on August 20th or August 18th and see where you're going to be on August 21st. Bring this covered mirror with you, practice until you're good at it, and that Monday you will be the hero of your neighborhood when you get to make a publicly viewable image on a nearby wall. If you have nothing else, you can make a pinhole projector. Just have a piece of cardboard with a pinhole in it, and then an image of the sun on another sheet of paper some distance away. But the image is really small. And as long as this is the way you want to see the eclipse, I have a much better suggestion. A colander. A colander is full of little pinholes. Bring your colander, is what you wash the fruit and vegetables in, right? Bring a colander with you on August 21. Hold the colander over your shoulder with the sun at your back, and the shadow you make on the pavement will show lots and lots of pinhole images of the eclipsed sun. And it is really spectacular. People come over and look at you like you're a magician. And then when you're done, it's a nice fashion accessory to keep the sun off you. So I suggest everybody bring a colander to work on August 21. But one way or another, we want to urge people, please, to not just protect your eyes, but make sure the eyes of everyone you know are safely protected on that day. Sunglasses are not enough, even if they're polarized. The various things that people have talked about, smoke glass and so on, they're not good enough to protect your eyes. The only other thing that works is welder's glass. If you have a welder friend, welder's glass number 14 or greater will also do it. But it's got to be number 14 or greater. Otherwise, either a projected image or eclipse glasses is the way to go. Now, as you've heard, we've been working with teachers, in particular with the National Science Teachers Association, for about 2 years, getting information out. And they've been really great at it. We have a book called Solar Science that we put together for teachers. And it's full of activities that teachers can do in the classroom. But I bring that up because part of that book was an 8-page layman's terms, non-technical, plain English introduction to the eclipse. And the National Science Teachers Association has very kindly put this entire 8-page booklet up on the web free of charge for anyone. For those of you here in the room, it's on your pink sheet that you got. But for everyone else, this is how you get to that free non-technical brochure, which has all the tables of when and where the eclipse is visible. You just go to NSTA.org. NSTA is National Science Teachers Association. NSTA.org/solar science. And you can download that booklet. It's free. It's a PDF file. Please feel free to send it on to other people you know. If you have people around the country who are not yet aware of the eclipse, please share the booklet with them. It's a public service. One shameless plug, we have written a book. Dennis Schatz and I have written a children's book called When the Sun Goes Dark, which is in the form of a story. 2 grandparents in the story are eclipse chasers. They look at eclipses for a hobby, and they explain to the grandkids what's happening with eclipses. And as part of the story, we suggest a series of activities that families can do with kids to get the kids ready for the eclipse. So for example, you can use a light bulb, a tennis ball, and a kid's head to simulate an eclipse. So there are various family activities in there. Some of you who came early, you got sample copies of the book, and please share that with a kid or a school if you're not into children's books. But this has quite a bit of good information, not just about solar eclipses, but lunar eclipses as well. So I want to just briefly mention some citizen science projects connected with the eclipse. And this is the one that you guys are very much involved in, and Calvin Johnson has taken a great leadership role in this. The Eclipse Mega Movie Project, photographers around the entire total eclipse zone are going to send wirelessly pictures of the total eclipse with the atmosphere of the sun showing wirelessly to Google. And a team at Google is going to stitch together pictures from all around the country into what's called a mega movie, a continuous movie showing what the sun was like as the eclipse moved across the United States. Now, the eclipse takes 1 hour and 37 minutes to go from Oregon to South Carolina. That's a lot less time than United, right? 1 hour and 37 minutes to go across the country. But during that 1 hour and 37 minutes, the sun's atmosphere varies quite a bit. It's a variable, active, seething, energetic kind of region around the sun. And so we will have an hour and a half record of what the sun was doing. during this time. It's really a very ambitious project, and I'm delighted you guys are putting it together. And then it's going to be available publicly when it's done, which is very nice. So not just scientists, but everyone in the country will be able to share in this wonderful movie. Another citizen science project is called Life Responds. It comes from the California Academy of Sciences in Golden Gate Park. And what they're looking at is animal reactions to the eclipse. We have a lot of anecdotal evidence about animal reactions. For example, because the sky suddenly goes dark, many farm animals think it's nighttime, and they do the thing they usually do at nighttime, which is go toward the barn or whatever they do. But their stomach and their eyes are not agreeing in terms of the time of day. So some animals look quite confused about why it's suddenly day, and why suddenly day has turned into night. As I say, we have lots of anecdotes about this, but what the idea here is that people will record animal reactions on a phone app and then send them into the academy, and instead of just anecdotes, we will have a database of how animals have reacted all across the eclipse path. Again, a very interesting project. NASA is all gung-ho about the eclipse. They have a special NASA website with lots of information. One of the things they have is what events are happening in each little city along the eclipse path. So if you don't just want to go to the eclipse, but you want to go to a music festival or a food fair or whatever else is going on, the NASA site is collecting all the interesting events along the path of the eclipse. They also have lots of good information and maps and so on. The American Astronomical Society has a website called eclipse.aas.org. And if you're photographing the eclipse, not necessarily for the mega movie project, but just for your own enjoyment, this website is probably the best to go to get information about photography, both regular still photography and video photography. There's a whole section with lots and lots of good information and links and safety considerations, etc. So this is a very reliable site in general for eclipse information, eclipse.aas.org. Well, just a word about why eclipses are such a big deal, and we don't get them that often. This is another feature of the solar system that many people are not aware of. The moon's orbit is tilted relative to everybody else's orbit. If you, for example, consider the orbit that we make around the sun, and then you look at the orbit of the moon, it's tilted by about 5 degrees. And that tilt means that as the moon goes around us, and the moon, by the way, goes around us once a month. You say month, but it's really moon, right? The moon goes around us once a month, and every month there is a time when the moon and the sun are in the same general part of the sky. But because of this tilt, think of it as two hula hoops, because of the tilt, on a typical month, the moon is either below the sun or above the sun. And so there's no eclipse in a typical month. But as you can see in this little diagram, twice a year the hula hoops cross. So roughly every 6 months we have what's called eclipse season, when eclipses become possible because the orbit of the moon crosses the orbit that we make around the sun. And so the result of that is that somewhere in the world an eclipse is possible every 6 months. It's not always a total eclipse. Sometimes the moon in its orbit is a little further away and we don't completely cover the sun. Sometimes the angle is such you only get a partial eclipse. Sometimes you get a lunar eclipse. But generally, every 6 months an eclipse is possible. And then we often get a total eclipse, but not over populated territory. 2/3 of the Earth's surface is water. And so it's very likely that a typical eclipse will fall over just ocean or a couple of barely inhabited islands. And rich people, usually retired rich people who have time and money, will often go to those places, and that's their hobby, to chase eclipses. But very few people will actually get to see the eclipse. because of the way the geometry worked out this time, this is a very democratic eclipse, and it falls over a richly populated area which has access to the web, right, and cars. And so there's going to be a much greater interest in this eclipse than I think any other eclipse in history. This is really the first US eclipse of the internet age, of the Google age, right? Information will be available to people all over the web. And so we are very, very excited and scared about how much public involvement there will be in this eclipse. Now, this is quite a contrast from times in past when eclipses were not predictable like they are now. These days, we can predict eclipses hundreds of years in advance. But back when they were not predictable, you can imagine our ancestors got pretty upset when, for no reason whatsoever, in the middle of the day, the sun went out. And the legends that we have recorded is that they thought some monster was eating the sun. In Asia, there were a lot of discussions of a dragon eating the sun. And they said, what can we do? Well, the idea is to absolutely frighten this monster or this dragon away from the sun. That's when the tradition arose of having pots and pans with you when you come out to the eclipse, and banging them together, making a really loud noise to frighten the dragon. And you know what? It always worked. That's right. It always worked. And so the monster went away and the sun came back. Today, we enjoy eclipses for their scientific value. Here's a little diagram showing the outer layers of the sun beyond the photosphere, the outer edge of the sun. There are several layers, complex, energetic layers, including something we call the chromosphere, closer to the sun, and then the giant outer atmosphere of the sun called the corona. And you'll notice here on the slide that the corona is hotter than the inner atmosphere and the surface of the sun. That's fascinating that the outermost atmosphere should be hotter than the inner layers of the sun's surface. And the answer is magnetism. There's tremendous magnetic activity in the outer layers, in the outer atmosphere of the sun. And the result is that it can heat up the particles in the corona and the outer layers to tremendous temperatures. Sometimes those particles actually boil off the sun. There's a wind, a gentle, regular wind of particles blowing away from the hot outer layers of the sun. And then every once in a while, we actually get a whole lump of material leaving the corona. That's called a coronal mass ejection. And it's hot, charged particles leaving the sun, moving away from the sun at reasonably great speed. And luckily, most of the time when one of these ejections happens, it's in a random direction in the solar system where there isn't anything. But every once in a while, one of these coronal mass ejections happens to be ejected right in the direction of planet Earth. And when that happens, we have to take precautions. It can damage sensitive instruments on our spacecraft out in space, and it can so overload the magnetic zone of the Earth that the charged particles coming down actually reach the surface and affect the power grid. We've had power outages and power surges as a result of these coronal mass ejections reaching the Earth. We call this space weather or solar storms. And one of the reasons we study the sun during eclipses and at other times is to learn more about predicting space weather. We're about as good at predicting space weather as we are at Earth weather, which is not very satisfactory. All right. Now, I wanted to show you Einstein laughing. And he's laughing here because I'm talking about eclipses. And I don't know if you know, but it's eclipses, a particular eclipse in particular, that made Einstein famous. In 1916, Einstein proposed one of his most outrageous ideas, one of the strangest theories in all of science, called the general theory of relativity, which predicts in very oversimplified terms that gravity can be thought of not just as a pull, but as a warping, a distortion of the very fabric of space and time itself. And this was such a ridiculous sounding idea that Einstein knew that it wouldn't be accepted even by his colleagues unless there was some direct proof, some experimental proof that space really did warp with gravity. Einstein calculated that the Earth's gravity is so weak, cosmically speaking, that the effect was impossible to measure in 1916 from Earth, on Earth, from the Earth's gravity. But he did calculate that one object in the solar system had enough gravity to have the warping of space near it be measurable, and that was the sun. And Einstein reasoned that if you could see beams of starlight coming right close to the sun, they would travel through slightly warped space. Those beams of starlight would bend in that warped space. And so if you look back down, back to the beam, to the origin of the beam, you would see the stars right near the sun in the wrong place in the sky. They would be slightly out of place because of this warping. Well, there's a small technical problem seeing beams of starlight come by the sun. What's that? Sun's a little bright, right? You can't see stars. It's daytime when the sun is out. But Einstein was no dummy. He knew about eclipses. Said, wait until there's an eclipse. During the total eclipse, the stars actually come out near the sun. You can see stars in the middle of the day because the sky right above you is dark. He said, wait till the next total eclipse and take a photograph of the eclipsed sun with the stars nearby showing. Look at the position of the stars in the sky, compare them to any star atlas where we have the positions of the stars. You will see that the stars closest to the sun will be in the wrong place by a small amount because of the warping of space. In 1916, World War I was going on. Nobody was going on any pleasure trips. But by 1919, the world had settled its differences, and there was an eclipse visible from an island off the coast of Africa. An international team of astronomers went to that island, took a photo of the eclipse. Here you see some of the newspaper versions of that photo, and found that the stars were out of place near the sun by exactly the amount Einstein had predicted. And this observation of the eclipse is what made Einstein famous. Before that, Einstein's work was known to nerds, but not to the general public. But after 1919, after this eclipse expedition, Einstein's name became public property. He became the best-known scientist in the world. And I love the headline from the New York Times, "Lights all askew in the heavens." How could you not read that article? Lights all askew. Askew means all over the place in the heavens. Men of science write, more or less agog. How can you be more or less agog? Either you're more agog or you're less agog. Over the results of eclipse observations, Einstein's theory triumphs. All right, well, let me finish up by noting that most of the time, when a country has an eclipse, it has to wait decades, maybe centuries, before another eclipse comes its way. But here in the United States, we are very lucky. It turns out if you miss this eclipse, there will be another eclipse in only 7 years. 7 years. Put the date, put this on your social calendar, is April 8th, 2024. There will be another eclipse crossing the country. You can see on this diagram that it crosses in an X shape relative to this eclipse. This eclipse is being shown from Oregon to South Carolina. Here it's going to come Mexico to Canada, but it's going to cross the United States as well. And so we will have another opportunity to use the glasses you got to explain things to the kids and enjoy an eclipse in only 7 years.
Where do I need to be if I want to be at the same place for both?
Turns out the place where it crosses is Carbondale, Illinois. That's why they're so excited. All right.
So they can keep their marketing material for 7 years then.
That's right. So this is the sky during the eclipse this time in August 21. I'm not going to go through this, but I will point out that just to the right of the eclipsed sun is Venus. So there will be one bright spot that everyone can recognize as the eclipse happens. Just to the right of the sun is the planet Venus. Well, I hope I've given you a lot to chew on. during this discussion. But I do want to say that one of the great things about the internet is that there's all this information available. One of the things that worries all of us about the internet is that there's a lot of misinformation available. And there's already a lot of discussion on the internet that this eclipse is the end of the world, that terrible things are going to happen, it's some sort of prophecy, etc. So let's try to not worry about those things. This is a perfectly natural phenomenon. The world will continue for good or for bad after the eclipse. If you, like us, are a little overwhelmed by the eclipse experience, there's always a little bit of this to take care of the problem. But more seriously, I want to wish all of you clear skies and good companions on August 21st. Thank you very much. Should I answer questions? I don't know how things work from the... Okay, great. Oh, here we go.
Will these also be useful for watching the occasional sunrise and sunset?
Yes, so the good thing about these glasses is that you can use them to watch the sun anytime. So here are the glasses, right? These are the Google ones, right? Yes, Eclipse Mega Movie Google. So you can use these glasses to watch the sun anytime. The main thing to watch out for is that especially if you're working with kids, that they don't crinkle or put any holes into the material that's in front of your eyes. As long as that material is intact, it's long lasting, you can use it, you can look at the sun for a long period of time and not hurt yourself. And yes, when the sun is again active, right now we're at what we call solar minimum. The sun's activity is at its lowest level in the 11-year cycle of solar activity. But in 5 or 6 years, when we reach solar maximum, when there are lots of sunspot groups on the sun, this is perfectly okay for watching the sun and seeing sunspots, or just watching during a sunrise or sunset. Absolutely.
So a couple of quick questions. What would you recommend for people who wear glasses? Can they use this kind of thing? Mm-hmm. And the other question is, can you watch the entirety of the eclipse with these glasses, or do you recommend just watching it for just a few seconds and watching again?
Great, so this is really important. First of all, if you wear glasses, just put these in front of your glasses. That's what I do, is I keep my glasses on because otherwise everything's fuzzy in the world, right? And so I just put these in front of my glasses and there's no problem. But so let's be really clear about when you need the glasses and when you don't. Anytime the sun is out, you need the glasses. Anytime there's a total eclipse, put the glasses away. You don't need them. So for those people going to the eclipse path, for the 2 minutes of the eclipse, don't use the glasses. You'll miss all the beautiful faint phenomena in the sky. You only need the glasses when the sun is out. Now, one more word, as long as you've given me this opportunity, let me say one more word about observing the eclipse. If you're going to go and see the total eclipse, I've already said, plan ahead. Make sure when you're there in the crowded zone, you have gas for your car, you have some food and drink with you, etc. But also, don't try to take a photograph if this is your first eclipse. The phenomenon itself is overwhelmingly beautiful. It's eerie, it's otherworldly. If you've never seen an eclipse, it's amazing. You suddenly see the sun go out, the stars come out, you see this halo around the sun. People are just going, oh my God, it's really an amazing thing. And there's only 2 minutes this time. It's a relatively short eclipse. Don't fiddle with equipment. Don't try to take pictures. Lots of people with lots of experience with taking, no offense, much better pictures than you, right? And they'll all be in the movie anyway. So just enjoy it. Take the glasses off during the total part and just enjoy it. If you can't go to this total eclipse because you haven't planned, then now you have 7 years to plan for the next one and see if you can take time off to be in the 2024 eclipse. Thank you for asking. Other questions, thoughts?
Thank you. Was just thinking that when I was a kid, I saw a solar eclipse. It wasn't total, it was in Europe. And in the times that we didn't have digital cameras, it was easy to make those glasses because I just used the film, but without being imprinted, the film that we had, and it was completely dark except for where the sun was.
Yeah, that's right. In the old days, we used to use many layers, not just one, I hope, but many layers of totally exposed film. Does anyone still remember film, right? In the era of digital photography, chemical photography has gone the way of the dinosaur. But yes, many layers of film were thought to be okay. Not so great, it turns out. This kind of plastic material is much better.
It wasn't exposed at all, so it was the one that is not exposed, so it's completely dark.
Completely dark.
Yeah.
Nevertheless, I recommend these over film.
Sure.
Yeah, absolutely.
Can you explain what's so special about those glasses? What is it made of and how do they work?
Yeah, oh, sure. So the glasses are just made of a mylar-like plastic. What it does is it's so dark, it's so good at cutting light out, that it cuts out both the visible light and the ultraviolet light of the sun. And so normally, right, it hurts to look at the sun. Your eye is equipped to react to staring at the sun, and nobody stares at the sun in their right mind. But during an eclipse, astronomical enthusiasm can overwhelm common sense, and people tend to look longer than they should. With these glasses, all the rays that can hurt your eyes are cut out, and you'll see if you try to put them on regularly, you can't see anything in any normal environment. You need the sun to be bright enough to get through these lenses. So these are very good at cutting out the vast majority of the visible light and the ultraviolet light. And as I say, if you can't get glasses here, many other places will have glasses. There's an organization in San Francisco called the Astronomical Society of the Pacific. They have glasses for sale. The Foothill College bookstore has them. I'm sure the Tech Museum and other places around here will have them. So check it out if you can't get them from Google.
And one note on that as well. If you're a Googler, we are sending them to a lot of remote offices. So if you're watching the live stream, we should have some at the lobby at the remote office, and we're handing them out in building 1225 here in Mountain View, which is where the Making and Science team is based.
Right. So maybe I should say that Google hasn't just restricted its generous donation to the libraries. There have been many other educational projects which have received Google Glasses. I know that, for example, the American Astronomical Society has a project to get glasses to underserved minority schools, to Indian reservations, etc. And you've generously contributed glasses to that project and to many other educational settings. So again, thanks all of you for being part of the Eclipse outreach for this eclipse. All right, well, thank you very much for coming, and I hope this has enlightened you a little bit. Enlightened, yes. You got it.